All right, trying something out. We're gonna try and do our work up here so we can have a recording of it, okay? All right, you guys, let's see here. I'm gonna go this one. We're gonna go blue, maybe. I have to hook one more thing in. Yeah, money.
That you always forget.
Same thing I always forget to plug in. Boop. Let's try this again. Okay. All right, you guys. So real quick, you guys understand the dimensional analysis. The simplest way to think about it was the whole nickels to dollars, right? So if I told you that we had 40 nickels, okay, so we have 40 nickels, okay? All right, and we want it into dollars, so we're gonna have $1 here. How many dollars equal a nickel?
20.
I said that backward. How many nickels in a dollar?
20.
20. Okay, so we got 20 right here. That's just going too slow.
Do you not have like that testing thing where like there's dots and you have to click the dots and it'll like...
I do. It's not lined up. It's just not writing very well.
Oh.
It's like that guy forgot how to be a pencil. He's out of batteries or something. Okay, so we got nickels right here. Okay, cool. Cross out nickels, right? And then we just do our math. We end up with dollars. How many dollars?
$2.
$2, because we have this guy. So we understand that this is the most simplistic version of dimensional analysis possible, right? Okay, cool. So now we're going to go through these steps real quick. We're going to go through these steps real quick. So if you guys look at step number one. Step number one. What's it want us to draw?
Write down the problem.
Write down the problem. Okay, cool. So we have 1, 2, 0, 0, 0 milliseconds. And we want seconds, right? Okay, cool. So let's put this in scientific notation real quick. What's it in scientific notation?
1.2.
1.2 times 10 to the what?
4.
4 milliseconds. And then we have a question mark about seconds. Okay, cool. All right, we good with that? Okay, next, I want you guys to drop down to your next box. So 2, it says draw your picket fence. Draw your picket fence. Okay, so we're gonna go like this. Okay, so we're drawing our picket fence. What goes here?
1.2 times 10.
So 1.2 times 10 to the, and then what is this?
1.
Milliseconds, okay? All right, and then what are we trying to find?
Seconds.
Seconds, so we want 1 second. Okay, what's this number always go over? 1, okay? And then, so now we have how many milliseconds in a second?
Wait, 0.003? No. 3?
Let's look at that, okay? All right, sometimes we try and decide, do we need it to be a -3 or do we need it to be a +3? So just think about this. We're trying to find seconds, okay? We have 1 second up here, right? We have 1 second, okay? Would it make sense that there's a whole lot of milliseconds that go into a second?
Yes.
Yes. If I had a negative sign here, would that be really weird?
Yeah.
So you just have to common sense this out every time. Okay? So now we got this set up. Okay, so let's see. Is this the same as this? Did I change anything? No. Okay, cool. All right, so now can we get rid of, so next, you guys, in your next line down, you guys should have this written in, okay? Choose the quantity or conversion formula sheet that relates. Okay, so did we just do that? So this was actually steps 3, and then we actually cruised right into step 4. Okay, so if you guys rewrite this down into step 4, you guys are good. So I see some of you guys copying, but here's the deal. I know you guys are used to just staring up at lecture because the lecture notes are available to you guys, but I'm not using the PowerPoints right now. I'm just making this quick video. And so videos are an awesome resource for like sitting down and understanding again, but they're not a good quick resource. This paper you have in front of you is your quick resource. So I did tell you to have a pencil for a reason. Some of you guys are still just staring. That's okay, we'll figure it out later or not. Okay. All right, you guys, cool. So now let's look at step 5. Okay, step 5. What does it want us to do in step 5? So we got step 3 done, we got step 4 done, now we're on step 5.
Double check.
So you guys need to write it out in step 5 so we can start slashing. Yes?
So does that entire just picket fence go?
Yep, in the next step down, in the next step down. Yep, I'm continuously doing this with you guys, okay? So the whole first sheet, the whole first page is one problem,
Yeah.
okay? And for some of you guys, it'll be easier when we do the example 2, because we'll just do it all at once, and you'll be like, oh, that's what I was doing.
But like,
Yeah.
so are all the steps from 3 and 4 inside just the picket fence?
Yeah, we're gonna put everything inside a picket fence,
Okay.
okay? And you guys will see how we do this later when we get to multi-dimensional analysis, but we'll be all right. What's up?
He wants to know what step 2 was.
Step 2, I think, was just getting it written down with this guy and this guy, I think, and this guy. Okay. All right. So now at step 5, it wants us to start slashing, right? So what can we slash?
The 1 and the 1.
Okay. So 1 and 1. Sure. I guess we can take the 1 and the 1. Okay. And then what can we do here?
Seconds.
Milliseconds and milliseconds. So what's left over? Seconds. Okay. Now here's the deal. Can we divide with exponents? We don't really divide. What do we do instead?
Subtract.
We subtract, right? So what we'll do is we'll bring this whole mess up here, and we're just going to take this guy, and we're going to subtract him up here. Okay, so this guy came to here, and then we can rewrite this over here. 1.2 times 10 to the first. Okay, so 10 to the first is what? 10. Okay, so what's our actual answer going to be here? 12 what? Seconds. And then we circle that. Okay? We just finished this problem out. You guys see how this is getting easier? Okay, I'll give you just a second to make sure you guys got all this caught up. So you guys like it's still not easy? That's all right.
Well, I kept getting it right pretty much every time on the thing last night, but sometimes I look at it and just confused.
Yeah, so here's the deal. These are easy problems. And doing an easy problem on this is difficult, but we're going to get to harder problems. And you're going to really appreciate the picket fence then, okay? All right, guys, so I'm going to clear this one out. All right. Okay, look at problem number 2. What's it say?
Convert 210 centimeters to meters.
210 centimeters to meters. So if we're following the rules, we're just going to write this down. 210 centimeters. And we want it to how many meters?
Yeah.
So now we wrote down the problem. Okay, so let's make our picket fence. We have 210 centimeters. Okay? We want it in meters. Can someone tell me how many centimeters are in a meter?
100.
100, so we have 100.
Yeah, I figured that.
All right, ready? What can we cross out? Wow, someone wants to like, no, you can't do stuff to my computer. All right, here we go, you guys ready? So we can do this. And then what do we have left? Meters. And then what is 210 divided by 100?
2.1.
Do we have the right answer?
Yeah, box.
What do you guys think?
No. No.
You add a 0 after the 1.
Deal.
2.1.
No, it can't be because if it's 202. Oh, never mind. Yeah. Okay, wait.
Wait, no, wouldn't it just
Never
be
mind.
2?
That's right.
Because there's no least amount of one page.
How many of you guys would feel more comfortable if we did it with
A 0?
how many of you guys would feel more comfortable if we did it with well, here's the deal. How many sig figs does this have?
2.
There's only 2 sig figs here, so whatever. But the other thing is, how many of you guys would feel more comfortable if we did it like this? 2.1 times 10 to the what? 2. And then, so that could be not that. And then, how about this? Instead of 100, we could write 1.0 times 10 to the what?
Second.
To the second, okay? And then could we subtract this from up there?
Yeah.
Minus 2. And then how many of you guys would feel better if it said 2.1 times 10 to the 0 meters? How many of you guys feel better about that? Because that's how you've been setting all your other ones up, right? Cool, so here's the deal. If you guys gave me this answer and the computer told me it was wrong or told you it was wrong, please let me know because I'll accept this. But starting today on your questions, it's going to ask you for either standard or scientific notation. So it takes the guesswork out of it. Okay? Does that make sense to you guys? All right, you guys feeling better about this now? Okay, we're getting moving. We're moving on. Good. Good, good, good. Okay, all right, so what's the next problem say?
It's
1.40 times 10 to the third power is equivalent to how many grams? Nanograms.
And this is NGs?
Yeah. NG.
Okay, and it equals, we don't know how many. Okay, cool. Let's set up our picket fence. Okay, so first of all, let's put down what we know, and that is 1.4 times 10 to the 3 nanograms. Okay, and then we want grams. Yes. Oh, is there a 0 after this one? Thanks, guys. Why is that important?
because it's a sig fig.
Because we need the sig figs later to write your answer correctly, okay? And remember, this tells us that we had to the 100th place on our measuring device, or our 10th place and we averaged the 100th, but there you go, okay? All right, so good, now I need to know about grams. You guys have the sheet open. How many nanograms are in a gram?
10 to the 9.
Now, let's think about this. Are nanograms smaller than grams?
Yes.
Yes. So would it make sense that we have this huge number, so that we could make this one?
Yes.
Yes.
Good. Because how many of you guys want to write a negative there? You have to think about it. If we wrote a negative right there, man, that's really, really small, right? Okay, it just gets even. So I think we're good on this one. Okay? All right, so now that being said, do we have it all set up?
Yeah.
Can we actually just do our problem now? All right, so let's slash. Okay? And then let's see. Once again, we don't divide, we just what? Subtract the exponent. So we're going to take this guy up here, and we're going to subtract a 9, okay? And then what's that leave us with? 1.40 times 10 to the negative 6 what? Grams. Is that the correct answer? We cool with that?
Yeah.
Okay, now, this is it for scientific notation, but if it said that we had to go to standard, we'd have to put a lot of zeros up there, right?
Yeah.
Okay, cool. All right, good. All right, you guys feeling this? I'll step aside. Some of you guys are still writing this down. Okay, that was just a recap of yesterday. Here we go again. All right, new stuff. What do we got? What's the next problem say?
Distance from the thumb to the little finger on Mr. and Mrs. hand is 4.5 inches. Convert this to centimeters.
Okay, so we got a word problem. Somebody give me the important numbers. What are we trying to do? What do you got?
You're converting 4.5 inches to
4.5 inches, and we want it to equal what?
centimeters.
How many centimeters? Okay, awesome. We're going from a non-base 10 measurement unit to a base 10 measurement unit. Super fun. So how are we going to set this up?
So 4.5 inches,
Okay, so 4.5 inches. Okay.
and then centimeters. Would you put 1 centimeter or like?
It's like, well, it's how many centimeters are in 1 inch? It's like 2.
Oh, okay.
Ah, okay, so let's look about what we want to get rid of. Okay. First of all, what do we want to find?
How many centimeters?
Centimeters. We want to find centimeters. Okay, so we know this can be centimeters over here. And then what do we want to get rid of? Inches. So we're going to have to put inches down here, okay? All right, so now, what do we got here? So how many, we got how many inches? So how many centimeters in 1 inch?
2.54.
2.54. 2.54. Okay, cool. So now, do we have this set up correctly?
Yes.
Yes. So can we get rid of inches now?
Yes.
So we got rid of inches. Life's good. Okay, do we have to put the 1 under here?
Yes.
We probably should, right? Because we know that's there. Okay. All right. So now 4.5 times 2.54. Anybody got their calculator out? Or your computer on there? Just knock that out real quick. Okay. You know what's funny is some of you guys are lazy for not having a calculator out, but the fact that you did math really quick to know where the ballpark would be is going to help you out later. So what do you got? 11.43 centimeters. Now, real quick, how many sig figs do we have up there?
2.
2. Okay, 2 are what we need. So what's this going to be?
11 point.
Wait, no.
0.
11.
11.
Just 11.
11.
It's the left.
Yeah, more.
11 centimeters. Okay? You guys are doing really good. Yesterday, you guys had no idea what the heck I was talking about. And now you're really rocking through dimensional analysis with a non-base 10 system into a base 10 system. What? You guys are tearing it up. Okay, let's see what we got next.
Convert 210 centimeters to inches.
Okay, so let me clear this, sorry. 210 what?
Centimeters to inches.
Equals how many inches? Okay, cool. So we're going to set this guy up, right? Cool. All right, so what's the number we're dealing with here?
210.
210. You know what we should probably do with this one?
Put it in scientific.
Let's put in scientific notation, okay? So we have 2.1 times 10 to the what?
2.
2, okay? And then these are centimeters, okay? And what are we looking for again?
Inches.
So we want inches right here. Okay, so this is kind of funny. We got inches and we got centimeters. How many of you guys are thinking ahead to your next math problem? How many of you guys like to divide and how many of you guys like to multiply? What if I told you you have a choice on here?
Wait, what?
Yeah, we could probably flip them. Right? But I'll tell you what I want to do. For this one, I want to just do inches as 1. Okay? I want to do inches as 1 because when we flip them, there's some rules that go to that. It's not the same numbers, is it? Does 1 inch equal the same amount of centimeters and the same amount of centimeters? It's not the same. It's different numbers. So let's just do 1 inch equals, so how many centimeters are in an inch?
2.54.
2.54. Okay, 2.54. All right, so are we all set up? And what are we looking for again?
Inches.
All right, cool. So let's do this. We're gonna cross out our centimeters. And you're like, oh, panic. Dude, I don't even know how to do this to the 10. Or do we?
Times 10 to the 0.
Ah, it's times 10 to the 0. Cool? Yeah, so we subtract 0. Okay, that was easy, right? But we still have to do what? We still have to divide. So what do you guys got when we divide?
82.667.
That sounds about right. 82.6. What's that long number?
No, it's
77165.
0.8.
I know.
I don't know. There's a lot of numbers there, right? But let's go back to our sig figs. How many sig figs do we need? Okay. What? Who said 3? Why did you think 3? How many do we need? We need 2 because this guy doesn't count. This guy without a decimal is not a sig fig, right? So we just have 2 sig figs. So we're going to be okay with 82 what?
83.
Sorry, 83. Don't mind my math. What did I mess up on that?
Everything.
I didn't round to everything. Your life sucks, mister. Okay, so you guys, we got that done, okay? All right, we got one more, right? Do you have a question?
With that one, instead of doing, I had centimeters as 1 and inches as 4.0 times 10 to the negative first, and I did multiplication instead of division, and I got 84.
Good. 84?
Yeah.
And you used what again?
I had 1 centimeter and 4.0 times 10 to the negative first for inches.
Right, we'd have to check the math on that. So for now, I'm gonna go, until we check the math.
Okay.
Okay? All right, let's jump on this next one, guys, okay? This is our last one before you guys get to do your work, so let's roll through it quick, okay? So here's what we want, you guys. What's the number they gave us?
3 gallons. Wait.
3 gallons into. Oh, wait, no.
Oh, they're supposed to make a recipe that takes 3 gallons, but they only have 2.5
3 gallons.
liters.
Oh, we don't have enough, so we have to change our recipe, right? So what do they give us?
Gallon?
They give us 3 gallons.
3 gallons, so is it 3.0 gallons or is
Yeah,
it
3.0.
3.0 GAL, okay? And what do they want?
Liters.
Liters, that's capital L, right?
Yes.
Okay, so they want liters. So we wrote down our problem. Life's good. Now we just got to use our picket fence. Okay, so we have 3.0 gallons, right?
It's not gonna be enough.
It's not going to be enough? Okay, so now on this one, you guys, we want to get rid of gallons. So we can make 1 gallon down here. So how many liters are in a gallon?
3.7854, so 3.8.
Let's just do 3.785 because then we don't have to worry about rounding or dropping off because that point would work for both. Okay, does that make sense? Okay. All right, so we got that one, and then what is that? Liters. Okay, cool. Now, do we have to do any crazy scientific notation stuff to this one?
No.
Yeah, we already know it's not.
We don't have to, right? And so what do we got?
30.78.
Right?
We got them though. If there's 4 liters in 1 gallon, then you have 3 gallons.
It tells us we need 11. Do we have enough?
11.355.
Don't have enough, right? So on this one, does the question ask us if we,
The recipe only takes 2.5 liters.
so is it enough?
Yes. Mitchell says yes.
How many gallons do we need?
11.
No, we need 3.
Sorry. We need 3 gallons, and then it's asking.
Don't we have to divide then?
This is cray. That's still 3.0.
Here's the deal, you guys. The answer is we don't have enough.
Because there's only 2 gallons, 2.5 gallons, or 2.5 gallons of it, or 2.5 gallons of it. And that's a lot less than 11.
So timeout. So you guys know what we need to know. We really need to know how many gallons we have, right? So maybe we have another problem to do. So check it out. What about this? We have 2.5 what?
Have a gallon.
Liters, okay? And then so we need to know how many gallons do we need, right?
Like 2.
What? So can we do this again for this problem?
Yes.
Yes, so let's do 2.5 liters. Okay, and then we need to go to liters again. So how many liters? How many gallons in a liter? That doesn't work, does it? So how many liters are in a gallon?
3.785.
So 3.785. Okay, and then that makes 1 gallon, right? Can we do our math now?
Yes.
All right, so we're gonna cross out liters, right? Somebody with a calculator, can you do the division on this?
0.6605.
It's repeating bar, right? 0.66. So according to our rules, we got 2 sig figs. We need 0.06 what? Liters, right?
Gallon.
All right, so now the question is,
No. Yeah, gallons. It's gallons, not liters.
sorry, gallons, gotcha. I'll actually erase that, sorry.
This is so stupid.
So you guys, we don't have enough to make our recipe.
So the parties were.
So the answer here, so there's a couple things you could do for this. First of all, you should write not enough. There's not enough, and we have 2 answers to talk about, and it's these guys right here. Okay? So you guys see how we did 2-dimensional analysis to come up with the answer on that one?
Yes.
Did they call it before
Yes.
we even started?
What's that?
I called it before we
Maybe. Some of you guys should be able to common sense this stuff out, but you can't common sense in the lab because they might tell you, oh, we don't have enough, how much more do we need? And you're gonna go, well, then you have to do your math, right? Okay? Question?
I was just
Yeah, same thing? Okay. Hey, you guys, really good.